Assalamualaikum everyone. Okay, so this is a lecture video, okay, for solving ordinary differential equation using Laplace transform, okay. So you have learned how to find the transform, and you also know already how to find the inverse of Laplace transform. Okay, so Laplace method can be used for solving first and second ODE. Okay, so I'm going to show directly the example from the ebook of John Bird. So how we can apply Laplace transform to solve ordinary differential equation, okay, is in the ebook of John Bird, page 645. I would like to explain problem 2, okay. So I'm choosing problem number 2. So I'm going to read the question here. Use Laplace transform to solve the differential equation. Okay, so this is the ordinary differential equation. So this is based on the second order. Okay, why it is second order? Because the highest degree of the derivative is 2. Okay, we have derivative of order 1. So this equation is called second order differential equation. So in this problem 2, the boundary values given x0, y equal to 3, and dy dx equal to 7. So this means that we are going to use this boundary value for solving the given differential equation. Okay, so the method here, first we write down the ordinary differential equation and then apply the Laplace at each part, okay, including the right hand side. So the left hand side of this differential equation and the right hand side, we apply the transform. Okay, where is the transform? This is the notation for Laplace transform, this L. Okay, so the one in the brackets here is the original differential equation. So find the Laplace transform for the second derivative here. Okay, and then there is 6 constant in this original differential equation. Okay, then the first derivative, apply the transform. Okay, and then plus transform for y. So we just write down transform for y and then transform the one on the right hand side. So the one on the right hand side is 0. Okay, so find its transform. Okay, so and then this is a correction. This one supposed should be written as d squared y over dx squared. So it's not d squared x over dy squared. There is a mistake here. Okay, so this is original, so we apply Laplace transform for all in the left hand side and the right hand side. This is right hand side, so this is left hand side. Okay, so therefore in the Laplace transform, okay, the transform for the one, we already know how to transform this, right? In when we refer to the Laplace table, correct? Okay, so this for the second derivative, this is the meaning. Okay, for the first derivative, this is the meaning. Okay, so this is given generally. So the one in the ODE is based on dy dx, correct? Okay, so this one is second order. So dy dx is here in the first order. Okay, so this means that whatever order of the differential equation, it will be transformed to the one given here in the brackets. Okay, so this one is not given, but you can refer because in your upcoming assessment, it is an open book, right? Okay, so this is for second order of differential equation. Okay, and this is first order of the differential equation. Okay, so remember the one that I put the arrow one. Okay, so you are supposed to use this one given. That is the transformation. Okay, so I'm going to explain. Whatever that we are going to change this second derivative, second ODE, and also first ODE into the one in the brackets. We have into this one and here. Okay, so the one inside here will be the initial value. Okay, so this means y0. This means when x is 0, what is the value of y? Okay, so this means when x is 0, then y prime means dy dx. Okay, so actually we can simplify because in the original equation, the boundary conditions are given. Okay, so these are boundary condition given. So is it given equation just now? Okay, so means that this part you can simplify to 3. Okay, so the y prime is equal to 7. Okay, so the y in this inside the bracket can be simplified to s squared ly minus, okay, this is s times 3, so we have 3s, then minus 7. So this is for the second derivative. Okay, so the one for first derivative, okay, will be here. Okay, so this one we can simplify to 3 just now. Yes, okay. So for this one, the one containing multiplication with 6. Okay, so inside the brackets, we have SLY minus 3. Okay, and then close the bracket, then it will be multiplied with 6. Okay, and this one, it will be remain as the same thing, ly. Okay, so the one on the right hand side, you may refer, because this is a constant of 0, correct? Okay, so means that we find the transform, because this is 0, so the transform is 0. Okay, but let's say this one transform for 2, for example. The one on the right hand side is equal to 2. So we write down L in the bracket 2. So the transform will be 2 over S. Okay, so remember, because 2 is a constant, so you may refer to the Laplace table, Laplace transform of 2. Okay, so 2 you can factorize because it's a constant, means that we find the transform for 1. So Laplace transform 1 is 1 over S, therefore 2 times 1 over S, it will be 2 over S. Okay, that is for example, but here we have 0. Okay, so I'm going to write down. Okay, after we simplify by looking at the boundary conditions given in the question and substitute into the second and first differential equation. Okay, so the one first part can be simplified to s squared plus transform of y and minus 3s, okay, minus 7. Okay, this is for second derivative, correct? Okay, so we combine with the one plus 6. Okay, so in the bracket will be s ly. So here is for first derivative. Okay, then minus 3. Okay, and then we combine with 13 ly plus 13 ly equal to 0. Okay, so this one is the answer after we find the transform. Okay, so this is for the second derivative. This is for first derivative. Okay, first derivative, but we simplified by substituting the boundary conditions given, okay, in the question just now. Okay, so we open the brackets, then, okay, so we open the brackets, then we have s squared ly minus 3s minus 7 plus 6s ly minus 18 plus 13 ly equal to 0. Okay, next we look at the part that we can simplify here. Okay, so the one containing ly, okay, the one containing ly, we allocate on one side. Okay, so the one with the constant, we combine it. Okay, so means that negative 7 minus 18, so we can simplify to negative 25. Okay, so I'm going to solve properly as here. S squared Ly plus 6s Ly plus 13 Ly then the remaining part bring it to the right hand side. Okay, I'm going to write down properly one by one so that you can see. I'm going to write down here will be minus 3s minus 25 equal to 0. Okay, so the one that the next step, the one that I underline here, will remain on the left hand side. Okay, so the other part that I didn't underline will be going to the right hand side. Okay, so the one that I underline here, factorize Ly. Okay, therefore, when we take out Ly, okay, the one I underline, so in the bracket we have s squared plus 6s plus 13. Then equal to 3s plus 25. Okay, so the one in the bracket, s squared plus 6s plus 13, bring it to the right hand side. So let Ly remain on the left hand side such that this one. From here to here, actually, we are using Laplace transform. Okay, so next one, we are interested to find what is the solution of y, correct? What is y? So therefore, this L is on the left hand side. L means Laplace. So when this L bring it to the right hand side, it becomes inverse. Okay, it becomes inverse. So this means that we can find the solution of y by finding the inverse of the one on the right hand side. Okay, so find this inverse. I'm going to write down again this one into a new screen. S plus 25 s squared plus 13. Okay, so look at here, the one in this bracket, okay, and look at the denominator part, okay, so we can check that it's not a part that we can find the inverse directly using Laplace table, correct? Okay, so means that the one in this bracket have to transform to the form that we can find the inverse. Okay, so first we are looking at the denominator. Okay, let's look at, we can write down the denominator by using completing the square. So it's here s squared. Okay, let's say s. Okay, so we have 13 here. So we can have 9 plus 4, correct? So here I can write down as s plus 3 squared. Okay, so when I have this one, s plus 3 squared, okay, so when I have s plus 3 squared, so when we expand this part, it becomes s squared plus 6s plus 9. Okay, then the number that is after the bracket will be plus 4. Okay, so we can check that in this denominator, we can have it as the relation to this part. Okay, so for example, I can have s plus 3 also. Okay. Okay, so if you're familiar already with the Laplace table, so you can check that when we have numerator and denominator that has the factor of same factor, so in the Laplace table, we can use the one containing probably the one containing 20. Okay, look similar to the one containing this one, number 20. Okay, looks similar, but let's look at there is a negative here, but there's no issues because this A can be negative value because negative and negative becomes positive. Okay, so our working solution later on will be referring to this form. Okay, so means that the one given in the right hand side just now must be modified so that it will be similar to the one here. Okay, so we are going to use number 20 basically. Okay, so there is a relation between numerator and denominator. Okay, if you want to use number 20. Okay, so now the next step is look at the numerator, how to make it equivalent. Okay, so let's say I just put it here because the numerator is actually 3s plus 25. So s must be times up with 3. So when we expand this bracket, it's actually 3s plus 9. Okay, but our constant actually is 25. Okay, so we have to add some constant, so that is equivalent. Okay, that is 16. So we modify this, the one here, to the new one. We haven't find the inverse yet. This is just to transform so that it is similar to the one inside the Laplace table. Okay, so when we this actually let's look at the numerator, we can separate this into two separate functions like this. I'm going to continue here. Okay, so I have like this 3 s plus 3. Then I have s plus 3 in bracket squared plus 4. Okay, plus here. Okay, so this one, because this is a constant, okay? So this one, we use number 20, okay? Because of this, similar. Okay, but this one, we're not going to use number 20. So now we refer back to the Laplace table. So the one in the numerator, there's no s. Okay, so we are going to use number 19. No s, yeah, it's a constant. Okay, but there is a b that we are supposed to make it similar at the numerator. Okay, so b. So in this case, now look at here. Okay, in this case, this b is 2. Okay, but I'm going to show to you one by one. Okay, so this one we use number 20. So here we use number 19. Okay. So next step, there is a constant strip, take it outside. So I'm going to write down like this. Okay, so on this number 20, so we have A, then B. Okay, AB, so we have EAT cos BT. Okay, so it's actually EAT cos BT. This is the general one after the transform. Okay, after find the inverse transform. Okay, so here I'm going to write down as, it says 3 here. Okay, so this is our A, this is our B. So A is our -3, B is our 2. Okay, so therefore I'm going to write down is A, e to the power -3t cos 2t. Okay, so this is the inverse. Now, on the other side, first it, okay, so this is actually, we correct down here because this 4 is 2 squared. This is 2 squared. Okay, so inside here 60, I can have 8 times 2. So when we refer to number 19, this is number 19. Okay, so the one numerator must have same value of b on the denominator. Therefore, okay, so 16 is 8 times 2. So 8 will be factorized here. Okay, so I can write down like this. We want to find the inverse of 8. Then we have 2 over s plus 3. Okay, or you can have, you can put here as minus, no problem. If you're already familiar, no need to write down negative, but just this one for me to explain, I will write down it directly. It's here. Okay, -3 squared plus 2 squared. Okay, so the inverse inside here refer to the Laplace table again. Number 19, so EAT sine BT. Okay, so I have like this. I'm going to write down like this. Plus 8 2 over s minus -3 squared plus 2 squared. So this is our B. Okay, this is our A. Okay, so here will be plus 8. Okay, then we have E to the power -3t. Then we have sine 2t. So this is the solution for the second ODE. We are going to try another example for problem number 3. Okay, so this is the original equation. It's very simple. Okay, so the first order transform to this form. Change it, okay, into this bracket. Then the first ODE dy dx will be here. Okay, this bracket. Okay, so but remember on the first order, we have to multiply with -3. Okay, then for the right hand side, transform for 9, then we get 9 over s. Okay, so this is important step. Don't forget to write down. Okay, now, similar like previous example, initial values are given, x0, y0, and dy dx is 0. So means that this can be simplified. Okay, when x is 0, so y is 0. The dy dx means y prime. So this part will be remain 0 also. Therefore, we have this part left. Okay, and then for first ODE, okay, this one will be 0. Then we have -3 times s left. Okay. So the simplification form will be s squared ly minus 3s ly equal to 9 over s. Okay, so it's very simple because our boundary condition is given 0, x0, y0, and dy dx is also 0. Okay, so we allocate ly, take it out ly, factorize. Okay, so now in the bracket we have s squared minus 3s equal to 9 over s. So ada ly. So the other part, we bring it to the other side. Then we have 9 over s squared minus 3s. So this means if we want to find the solution of y, find the inverse of the right hand side. Okay, so we have here order 1, we have order quadratic actually. So but when we times out, that becomes a cubic equation. Okay. Okay, now look at the one on the right hand side. So I map here. Okay, this is actually, so I'm going to continue writing down here. We can write down like this, y equal to 9 over, okay, s cubed minus 3s squared, correct? So actually the common factor is s squared. So I have like this. Factorize s squared. I have s minus 3. Now this one is very clear. Then we can use partial fraction to reduce the fraction because the one in this bracket, we cannot find the inverse directly, okay, from the Laplace table. Therefore, this fraction need to be reduced into partial fractions. Okay, so how to reduce the partial fraction? I'm going to write down like this. Before we find the transform, reduce this fraction. Okay. So this is power of 2. So they must have first one, power 1, power 2. Another constant, diffraction, s minus 3. Okay, there are 3 partial fractions here. So the next step is to find the value of ABC. So ABC must be constant. Okay, so remember we have to combine these 3 partial fraction becomes one single fraction. Okay, so let's look at here. A has S. Okay, out of this, A has S. Therefore, A should be multiplied with another one S and S minus 3. And then for B, okay, so look at the denominator. B has S squared from here, so B do not have this part. So B will multiply with this one. Okay, so C has this one. C do not have this part. So write down here S. Then they are having same denominator with this one. So the next step is to compare numerator part, the one I mark. Okay, compare the numerator as here. Write down. Compare numerator. Okay, so very simple one. We know that we are supposed to find ABC value. Very simple, we can choose S that is equal to 3. fastest result. Okay, when S equal to 3, so this part will be 3 minus 3, 0. So A will be times 0. B also will be times 0. So we have this part non-zero, means we can find the value of C. So this gives us 9. Okay, so this one you can substitute directly, but I'm not going to write down. I will just write down here as A times 0. Okay, because of this part 0, plus B times 0, and then plus C squared means 3 squared, that is equal to 9, then we have 9C. So the left hand side is 9 equal to 9C, so this will give us C as 1. Okay, so the next solution, so the next substitution, let's change or use x0. x0, okay, so we have left hand side as 9 equal to, so this part will be 0 because A times 0. Okay, so here when s0, so we have 0 minus 3, then here we have negative 3b. Okay, so this will be C times 0, so will be 0. So we can solve for this b, that is equal to negative 3. Okay, so next substitution, let's choose very simple number. We have try 3, we have try 0. So let's look at 1. Okay, so here we have A times 1. So 1 minus 3 is negative 2. Okay, plus B. So 1 minus 3, negative 2, then plus C. Okay, so next we have 9 that is equal to negative 2A minus 2B plus C. Okay, so we have 9 equal to negative 2A minus 2 times negative 3. Okay, where we got this negative 3 from this part. Okay, and then C is 1. Okay, from our previous solution. Okay, so I can write down as 9 equal to negative 2A plus 6 plus 1. So 6 plus 1, 7. So we bring 7 on the left hand side becomes 9 minus 7. So we have 2 equal to negative 2A. So this gives us the value of A as negative 1. Okay. So we have A negative 1. So I can put down here A is negative 1. B as negative 3. C as 1. Okay, therefore, this fraction has been reduced to 3 partial fractions. We can check here when we refer to the 3 partial fractions. Okay, each of these 3 partial fractions can be find the inverse directly from the Laplace table. Okay, so this means that the inverse of Laplace transform here, okay, is equivalent by finding the inverse of Laplace transform for these 3 partial fraction. Okay, so I'm going to write down like this. Okay, so now refer to the 3 partial fraction here. Okay, Laplace transform for this part. Can check in the Laplace table. It goes to this number 1, but there's negative, so you can take out the negative. So 1 over S, the inverse will be 1. Okay, so I can write down that this part is -1. Okay. Okay, next, -3. Take out -3. So inverse of 1 over s squared. Okay, so it goes to s squared will be similar to this number 3, okay? But it is as power. 3 is its power 2, so our n is 1. Okay, n is 1. For back, So here, our denominator is actually s power 2, therefore n plus 1 is equal to 2, n is 1. So 1 factorial is 1. Okay, so this one. So you can take out -3, so the remaining part will be 1 over s squared. So when we refer to the Laplace table, number 2, we have t to the power n. Okay, so we have t to the power 1. Okay, so if you didn't write 1 also no problem. I just want to show to you. Okay, the third part here, 1 over s minus 3, it goes to number 2. Okay, so we have e to the power 80. So plus e to the power 80, so a is 3. Okay, so our solution will be this one. Y equal to -1 minus 3t plus e to the power 3t. So this is the solution for the given second differential equation. Okay, so for this one, I'm not explaining for the example of first ODE because the example in second ODE here, okay, in problem number 2 and 3 contains the first ODE actually, okay. But of course, if you just have only first ODE in the question that you have to solve, that is very simple. Okay, so this one I'm showing the second ODE, but I hope you know how to do the same thing for the first ODE. Okay, so if you have any question, don't forget to ask me, or you can message to me privately. And please complete the tutorial question, okay, for this Laplace transform and its